Let's now briefly go through our structures. For that, we will create a new directory and new file. First, we will create a new structure with a name person with 3 attributes. Inside of our main function, we want to create p1 and p2 variables as data type person, and also we want to create that objects with pointers. When we print values of p1 and p2 variables, we can see the output of them. We want to know how we can access specific values of specific attributes inside of our structures. We can print values like this. We will access p1 variable, then we will write dot, which means that that variable will call something, and in this case we will specify name of specific attribute. If we want to print value of first name attribute, we will type p1 dot first name. The same pattern goes for all the others attributes. For example, if we want to print value of age of our p2 variable, we will type p2 dot age. In this case, age for p2 variable will be 34. Now we know how we can get specific values inside of our structure. Let's now see how we can set new values to our specific attributes inside of our structure. For this case, we will create a new structure with name animal. This structure will have 3 attributes. Let's create new object with data type animal. We specified that our animal variable will be empty object, and also that object will be connected with pointer. What is empty object? When we create empty object, this means that we created a new variable, we reserved place inside of our memory for that variable. Also that variable is connected with pointer, but values of this variable are not set up yet. In this case, we reserved only location for this variable. Let's set up new values of our attributes. First, we will access our variable, then we will write dot, and then we will write name of specific attribute which we want to change. Next, we will write sign equal, and then we will specify new value which we want to assign to our specific attribute. ID of our animal is equal to 1. The same pattern goes for 2 other attributes. Now we can print our animal variable. You can see the output. If you want to compare empty object with our new state of animal variable, you can print empty animal object like this. Here, when we print our empty animal variable, we can see object with pointer, but actually that object have values. How is that possible? In this case, we have 0 and we have 2 empty places. Each data type on creating has declaration. If we don't specify new value of specific attribute when we declare new object, each data type which we didn't set up with new value will have 0 state for that specific data type. First attribute inside of our animal structure was ID. That ID has data type integer. 0 state if we don't specify new value for integer data type will be number 0. In the next example, in case of a name attribute, we have data type string. We didn't specify new value as we didn't for our location attribute, and because of that, when we created empty object, name and location attributes has 0 state, which means that in this case, when we create our empty animal variable, name and location will be set up as empty strings. Let's now create all empty data types where we can see the real example of our 0 states. Here we specified 4 new variables where data types are integer, float 64, boolean, and string. These variables are only declared, which means that we didn't assign any new value. When we print these 4 attributes, we can see values of them. 0 state for integer will be number 0. 0 state for float 64 will be also 0. 0 state for boolean data type will be false, and 0 state for our string data type will be empty string. In the next video, we will see how we can create our custom type, and we will write structures which don't have global definition. To create a new custom data type, we have 3 stages. First, we must specify that a new object is type. First, we will write reserved word type. Then, we will write new custom name for our new custom data type. Let's say we want to create type price. After that, we will specify which data type will be transformed into our new type. Let's say that our new type price will have characteristics of our float 32. Now, in this case, on specific places, we don't have to specify float 32 data type. We can create new variable as data type price. Before we start to write new code, we will create another new custom data type. In this case, we will have new custom data type with name level, and that level will have characteristics as integer 8-bit data type. Let's now create new variables with our custom data types. Inside of our main function, we created myPrice new variable, but data type of that variable is price, not float 32. Then we assigned new value to our myPrice variable, and when we print type and value of our myPrice variable, we can see the output. Let's do exactly the same thing with our custom data type level. We created myLevel new variable with data type level. We assigned new value as 4 to our variable, and when we print type and value of our myLevel variable, we can see the output. We have value 4, we have data type level, which is created in our main. Let's now, inside of our main function, create 4 different custom data types. Here we created 4 new data types with names, minutes, weight, title, and answer. So now we want to know how we can initialize our new variables with our new custom data types. First, we will type name of our new variable, let's say like this. Then we will use our operator to initialize our new variable, but this time we have different picture. We won't assign only value, but also in front of value we will specify specific custom data type. In case of minutes data type, we will specify that name of data type, and then we will open brackets. Inside of our brackets, then we will specify specific value which we want to assign to our minutes variable. We have variable minutes as a data type minutes with value 37. We can do exactly the same thing for other 3 data types. We assigned new values to our new variables with our new custom data types. Let's now print types and values of our new variables. As we can see, we have new custom data types and values of that variables. Our new variables have new custom data types, and we assigned values to that custom data types. Let's now see how we can create new structures without global definition. Now we want to create new structure without global definition. What does that mean? It means that we want to create structure inside of our function to declare that structure and to assign new values to that structure only inside of our specific function. That structure won't have declaration and definition outside of our functions. This kind of structures is also called as anonymous structures. How we can create that kind of structure? We will create that new structure as a new variable. First, we will type p1 as our new variable. Then we must declare that our variable is new anonymous structure. We will write reserved word struct. And then we will open our block. Inside of our block, we will create new attributes. Let's say we want to create two new attributes like this. This new anonymous structure have two attributes, first name and last name. How we can add new values to that structure? We will open another block. Inside of our second block, we will specify values which we want to assign to our attributes. So, in this case, we must assign two values with data type string. Now, when we print our p1 variable, we can see that that variable is structure with specific values. Let's create another example. We have new variable car, which is anonymous structure with attributes max speed and weight, and we assign two new values to that structure. We want to investigate specific type of that variable and value of that variable. As we can see, data type of our variable doesn't have the name. Type of our car structure is a struct with two attributes. Our structure doesn't have global name and doesn't have global declaration inside of our application. But in any case, we can see specific values of our structure. Also, it's true that we don't have global declaration, but that doesn't mean that we can't access to specific attribute. In our car variable, we can access, let's say, our max speed attribute and assign new value. Now, when we print again our car variable, we can see that specific attribute of our anonymous structure has changed the value. We have great flexibility right there. Also, we can create our anonymous structures by combining multiple structures which have global declaration. Let's now see how we can do that. In this case, we will create two new structures which have global declaration with names user and developer. We want to create anonymous structure by combining these two global structures. We created a new p1 variable, which is anonymous structure, and that structure has two new attributes, where first attribute will be user structure and the second attribute will be developer structure. When we want to assign specific value, we must assign specific structure. In this case, for first value, we will assign user, then for that attribute, we will create new user and value inside of that user will be James. Next attribute will be developer, and for that attribute, we will create new developer with values 413 and Golang. When we print p1 variable, output will look like this. We can see that type of our p1 variable is anonymous structure, but that structure has two attributes. First attribute is user structure created in main, and second attribute is structure developer created also in main. Value of that anonymous structure are values combining from these two structures. The real question is how we can create global structures with combining multiple structures. For that, we will create inheritance inside of our structure, and in next video we will see how we can create that kind of structure.